Hi, everyone. Welcome to your first e-learning assignment for algebra. I know we started learning how to graph parabolas, which are quadratic equations, quadratic functions, the ones that make the U shape. But since you probably won't have graph paper at home, we're going to wait to graph those till we come back. The section that we're going to study while you guys are off for the next 2 weeks is how to solve quadratics by factoring. Obviously, since we're going to be using factoring, I want to dedicate today to just review all the different types of factoring that we did in Chapter 7. If you look at number 1, it's a binomial. I always tell you, always check for GCF. I even showed you a trick on your calculator to check for GCF. You take the smaller number, so that would be 9, divide it by the bigger number and reduce. And then divide the numerators, the two numbers on the top, and that's your GCF. Always check for GCF first. Remember that you should be doing all of these problems on a separate sheet of paper, so copy one problem at a time. You can always stop or pause the video when necessary. Number 1 is a binomial. We know that the GCF between the coefficients, or the numbers in front of the variables, is 9, but they also have an x in common. So we're going to say that the GCF is 9x. The GCF goes in front of the parentheses. Remember that factoring is rewriting something into a multiplication problem or rewriting it as a distribution problem. Divide each piece of the binomial. So 18x squared divided by 9x becomes 2x. And then any number divided by itself. So like 9x divided by 9x becomes 1. Check the binomial that's left inside the parentheses. Is it a difference of squares? No, it's got addition. If it had been a difference of squares, we could have kept going. But for now, that's all we can do. Next one. I'm going to check for GCF. Does 25 over 30 reduce? What does it reduce to? Try it on your calculator or do it in your head. It reduces to 5/6, which means the GCF is 5. The two terms in this binomial have an a in common. So I'm going to divide them by a. What you take out goes in front as your GCF. The remainder comes from dividing the two portions of the binomial. 25 divided by 5 is 5. You had a squared. You took 1 away. There's 1 left. 30a divided by 5a, the a's cancel, and you're left with 6. Look at what's left in the parentheses. Is it a difference of squares? Nope, because it's got addition. So then we're done. Remember, you can pause the video at any time that you want, and you can also rewind. Okay, next problem. I see a 9 and a 25. I'm going to take the smaller number divided by the bigger one. Remember, you ignore any positives or negatives when you're using this trick. Reduce it. Take a minute and do that in your calculator or in your head. It comes out the same. So that means the GCF is 1. They also don't have any variables in common. So even though there's no GCF, we learned another strategy of factoring binomials that have a subtraction and have squares. This is a difference of squares because if you square root 25, you get 5, which is a whole number, not a decimal. If you square root 9, you get 3. The square root of w squared is just w. So since I can square root each piece and get a whole number, it's a difference of squares. So the difference of squares, take the square root of the first term. That would be 5w to the first power. Square root the second term. That's the second part. which is square root of 9 is 3, then make 1 plus, 1 minus. And that's how you factor a difference of squares. Pause the video and try number 4. Check for GCF. Then ask yourself, is it a difference of squares? Okay, pause the video now, try the problem, and then unpause the video when you're ready to check your answer. Okay, 49 over 169 did not reduce. That means the GCF was 1. But it was a difference of squares because the square root of 49 is 7 and the square root of 169 is 13. And also the variable is squared and it's got subtraction. Remember, you need to have subtraction. It has to be a binomial, and you have to be able to square root the two terms in order for it to be called a difference of two squares. Make sure that you have one with a plus and one with a minus in your answer for the binomials. Okay. Always check for GCF. So I'm going to take a minute and see if I could reduce 12 over 75. I can. I get 4 over 25. That means that the GCF is 3. They also have an a to the first power in common. What you take out goes in front of parentheses. We'd be left with 4a squared minus 25. Look what's left in the parentheses. It's a difference, it's got subtraction, and I see an a squared. I can square root 4 and I can square root 25. So I can keep going. This is the one that factors into 1 plus, 1 minus. It's a difference of squares, binomials. Bring down your 3a, because you can't lose the GCF. Square root of 4a squared is 2a. Write it in both binomials. Square root of 25 is 5. Remember, you need one with a plus and one with a minus. Go ahead and pause the video if you feel like I went too fast, or stop the video whenever necessary. You could always rewind. And number 6, it's a binomial. Always check for GCF. 45 over 80. Go ahead and take a minute and see if you could reduce that. 45 over 80 reduces to 3/5. So what's the GCF? 15. They also have a p in common. So I'm going to divide by p to the first power. Okay, put the 15p out in front. Divide each of the terms. Okay, so 80 divided by 15 I just realized I reduced that wrong. Pause for a second. Super sad. 45 over 80 reduced to 9 over 16. That means that the GCF is 5, not 15. Okay, so now you've got 80 divided by 5, that's 16p, and then squared because you had 3 but you took one out. Negative 45 divided by 5 would give you negative 9, and then the p's cancel. If you look, what's in the parentheses is a difference of squares. It's got subtraction, the variable is squared, and you can square root each of those numbers. Square root of 16 is 4, square root of 9 is 3. So we can keep going. Square root of 16p squared is 4p. Put it in both binomials. Square root of 9 is 3. And make sure you have 1 plus, 1 minus. And don't forget to bring down the GCF that you took at the beginning. Okay, number 7 is a trinomial, quadratic trinomial. If you look, it has two coefficients that are both 1s. In any case like this where there's coefficients of 1, the GCF is not going to be anything bigger than 1. So in terms of GCF, it just has a 1. But with the trinomials, you have to try to find two numbers that multiply to the outside two numbers. So 1 times negative 42 is negative 42, and add to the middle number, which is negative 1. So as you start to make your list for the factors of 42, look for two numbers that either add or subtract to give you 42. So here are the factors of 42, 1 and 42. Does 2 go into 42? Yeah, 21 times. Does 3 go into 42? Yeah. Does 4 go into 42? Nope, we get a decimal. Does 42 divide by 5? Nope, we get a decimal. Does 42 divide by 6? Can it be divided by 6? Yep, we get 7. And that combination is the one we want because that can be subtracted to get 1, or we can add it with some positives and negatives. So now what you want to do is check the signs. Would this work if the 6 was negative? The answer is no. Would it work if the 7 was negative? The answer is yes. Once you find the two numbers, ask yourself, can I use the shortcut? You can use the shortcut if the leading coefficient for the quadratic term is a 1. So put a variable in each binomial of the answer. We chose a positive 6 and a negative 7 from here, and that's your answer. Number 8, same thing. If any of the numbers have a 1 as a coefficient, the GCF is not going to be anything bigger than 1. So I check for GCF. The GCF is only 1. Now I'm going to multiply the first and the last number. I get 1 times negative 3 is negative 3. And I need to find two numbers that add to the middle number, which is 2. So the factors of 3 are just 1 and 3. So it's got to be 1 and 3. Try it with a negative 1. Does that work? Yeah. I can use the shortcut because the leading coefficient was 1. So I'm going to put x minus 1 and x plus 3 because those are the numbers we said worked that multiply to negative 3 and add to 2. Remember, you can pause the video and rewind anytime you want. For the next two problems, I noticed that the trinomial, it looks like they could have a GCF. So I took the smallest number, which was 3, and I divided it by the two bigger numbers. In number 10, I took the number 5 and divided it by the two bigger numbers. So now I want you to reduce 3/15 and 3/18 for number 9. Pause the video and then unpause it when you have them reduced and have found the GCF. You should have gotten a GCF of 3 for both. That means that 3 divides all of these numbers. Unfortunately, they don't all have an x, so I can't say that the GCF is 3x. It's just 3. All right, here's my GCF. I'm going to be left with 1x squared minus 5x plus 6. Because this is a quadratic trinomial, I need to check two things. I need to check to see if there are any numbers that multiply to positive 6 and add to negative 5. So I want you to pause the video right now and find the two numbers that can multiply to positive 6 and add to negative 5. You will be able to use a shortcut since the leading coefficient is a 1x squared. So once you find your two numbers that work, you're going to put them in the answer, the binomials, when you're ready. So pause the video right now, find the two numbers, and try to factor. Unpause when you're finished. Okay. Hopefully you did not pick 1 and 6. 1 and 6, no matter what combination of positives and negatives you use, will not work It has to be -2 and -3 that multiply to +6, and -2 plus -3 that add to -5. Okay, go ahead and pause the video and find the GCF between 5 and 40 and 5 and 100. When you're ready, unpause the video and check your answer. Okay, I got an answer of 5. Not all the terms have a variable of n, so the GCF is just 5, not 5n. Okay, now I'm going to divide each of the terms by 5. That gives me 1n squared minus 8n minus 20. If you notice, we have a quadratic trinomial left inside the parentheses, so I have to check to see if there are two numbers that multiply to -20 and add to -8. So take a minute, pause the video, list all the factors of 20, and see if this is possible. Unpause the video when you're ready. The two numbers that work are 2 and -10. 2 times -10 equals -20, and 2 plus -10 equals -8. I can use this shortcut since the leading coefficient is 1. Drop down the 5 that you took out at the beginning, and then put your variable in each binomial of your answer. Remember that we chose to use a +2, so +2 in one binomial, and -10 in the other. Okay, for number 11, check to see if there's a GCF. Pause the video and then push play when you are ready. Number 11 does not have a GCF, but it is a quadratic trinomial, so I need to see if I could find two numbers that multiply to 24 and add to 11. So I'm going to start by listing all the factors of 24, starting with 1 and 24. Can you divide 24 by 2? Yes. Can you divide 24 by 3? Yep. Can you divide 24 by 4? Yep. Can you divide 24 by 5? Nope. Can you divide 24 by 6? Yep, it's already on there. Remember, when you check a number that's already on your list, that means you've found all the factors. Which of these numbers, or each pair, will add to 11 or subtract to 11? 3 and 8. There are no negatives in this problem, so I don't need to worry about negatives. Now, because my leading coefficient is not a 1, I have to factor this by splitting the middle term. So the middle term is going to be split into a 3y, a positive 3y, and a positive 8y. The front term, 4y squared, and the 6 need to be brought down. So we have split the middle term into 3y and 8y. Okay, now we check for the GCF of the first two terms. The GCF of the first two terms, 4y squared and 3y, is just y. The GCF of the second two terms, 8y and 6, is what? If you said 2, that is correct. Okay, so the two GCFs that you found go in the first part of your answer, so y and positive 2. And now you're going to divide this 4y squared divided by y is 4y. That goes, remember these are your remainders. R1, remainder 1, remainder 2. It's going to go in the second part. This was your GCF from the first pair, GCF from the second pair. Okay, so 3y divided by y is just 3. And that's your final answer. Remember that these should also give you the same answer as R1, and this is R2. Remainder 1, remainder 2. Feel free to pause the video, rewind at any time. Okay, does number 12 have a GCF? Pause the video, take a minute, and see if 12 has a GCF. It does not. But it is a quadratic trinomial, so I need to find two numbers that multiply to 63 and add to -2. Take a minute, pause the video, and give me all the factors of 63. Okay, now that you have your list of factors, which pair can I use that will add or subtract to -2? Hopefully you can see that it's 7 and 9. Now take a minute and figure out which of those has to be negative. If you said -9, you're correct. Because the leading coefficient is not a 1, I need to split the middle term to the two numbers that I said add to -2. So I'm going to use a +7 and a -9. Remember, you have to put the variable on them so that they add to give you -2, which was in the original problem. Now I'm going to take the GCF of the first two terms, which is just 1a, and I'm going to take the GCF of the second two terms, which is not 3, -3. If you take 9 over 21 and reduce it, you get 3/7. So the GCF is 3, in case you're wondering where I got the 3. Okay, for your answer, you're going to have your first GCF, your second GCF, and then in the second binomial, the remainders after you divide these. Remainder 1, remainder 2. 3a squared divided by a is 3a. 7a divided by a is 7. Okay, at this point, I want you to pause the video and try number 13 and 14 by yourselves. When you're ready to check your answers, go ahead and push play again and see if you did them right. Try not to cheat. Do 13 and 14 by yourself, so pause the video, and then when you're done with them, unpause the video and check your answer. And that's all for today. Make sure that you are writing all these problems on a separate sheet of paper and keeping them organized for when we come back. Okay, hopefully you did them right, but if you have any questions, feel free to send me a message through Remind, and I'll help you. Okay, see you soon.